is what we're going to be doing today. So the idea here is that we're going to use some, we'll quote unquote, real world data and model a linear function based on that. Not a whole lot of stuff, is linear in the world, but there's a good bit of stuff that is linear. And if you're looking at a scatter plot, which is just a collection of ordered pairs plotted here, I've got a bunch of dots going on, and they tend to trend in a straight line. That would be a positive linear relationship out of that. And we could come up with an equation that models that, which would allow us to predict what's going to happen in the future based on that. Or even go back to what we think could have happened in the past, depending on where our data is that we're given. Okay, so positive linear correlation there. We got a slope-intercept form equation. The slope is greater than 0, so it's a positive slope. Okay, it's going up and to the right. Same thing here. Got a set of ordered pairs. We plotted them on the coordinate plane, and they kind of trend into a line going down and to the right, and that would be a negative linear relationship out of that if that's going on. All right, so recognizing those things, you've seen that stuff before. It's nothing new there. But the ordered pairs we're going to be given in either in a table format or some sort of way. They're going to give us that information. We're actually going to use the calculator to draw that scatter plot instead of doing it by hand. Okay, and then we're going to use the calculator to help us find a line of best fit as well. Okay, so another relationship would be this one, where it's fairly constant. In statistics, you'd call this like a uniform distribution, but it's just straight, horizontal line there. When it's horizontal, the slope's 0, and so you get this equation, y equals some number, whatever number it's crossing the y-axis at, out of that. So we get it's a linear relationship, though. We can see that that's going on, and then you have nonlinear relationships. There are tons of nonlinear relationships. There's no correlation, where the dots are just kind of random out of there. But sometimes the dots will kind of line up and make some sort of shape. And usually when they do that, there's an equation that goes with it. It just doesn't have to be a linear equation. We're going to build toward being able to find those other equations. The next two sections in chapter 4, section 3 and 4, talk about quadratics. And we're actually going to do some of the same things with quadratics and finding the equation of the quadratic based on a set of ordered pairs and all that. And we can use the calculator to help us do that as well. There's a lot of different other models that could happen with that that we talk about. One of my favorite classes in college was a mathematical modeling class. And it was just, we did experiments about every day and got data and then found the equation that went with that data, whatever kind it was. The thing with that was, it was a college class, so we had seen everything. So we had every equation type possible to fit to that data. And then we would rule out the ones that, okay, this doesn't look linear, so it can't be a straight line. It doesn't look quadratic, so it can't be an x squared graph. We rule those things out. So the idea here is that we're going to begin that process of, okay, is it linear or not? The human eye really detects linear things really well. Other stuff not so well. But let's look at, I'm pulling some questions that are in your homework, but all we need is the table. Okay, so I'm just referencing where I got that. Was in your book on page 292. You don't have to have your book out to look at this. Just get a set of ordered pairs. So this data came from somewhere. Doesn't really matter where it came from, but it's just data. And we've got, 6 sets of ordered pairs. Okay, 6 ordered pairs out of that. So we got 6 x values and 6 y values. Okay, what we want to do is decide, is that a linear relationship? And if it is, we're going to do 2 things. We're going to find a line of fit, and then we're going to find a line of best fit. So a line of fit and a line of best fit. That's going to be our 2 jobs that we're going to do today. Okay, so what we want to do first is look at the points on the coordinate plane. So I'm going to teach you how to do that with the calculator if you don't already know how. So with the calculator, everybody get it out there because there's a little process we want to go through. I just want to make sure everybody's is set the same first. So everybody get a chance to get that out, get it turned on. We're going to hit the stat button. And then before we start doing the problems, let's just everybody hit number 5 for setup editor and then hit enter. Stat button is just right beside the circles there. And then hit number 5 and enter. You won't have to do that every time. What that does is if your calculator for some reason was kind of reset differently, that sets everybody's the same. You don't have to do that every time. Okay, so that's just to get everybody on the same page. Now, here's what you do each time to get these scatter plots drawn. Okay, so to do that, you're going to hit stat, and then we want to edit some lists. So the first menu that comes up when you hit stat is the edit menu. We want to select number 1. And it comes up to a page that looks like this. Okay. Anybody not able to get there? All right. Mine's got some data in it from some class. I don't know when I did this. Okay. So I want to get rid of that. Yours may have some stuff in there as well. If you want to delete a list, you can delete each piece individually, but that seems like it could take a while. So the fastest way to do that is just press the up arrow until the L1 here is highlighted, and then hit clear and enter. Hit clear and enter. You got to hit enter to get it to go away. And it empties out that list. I'm going to do the same thing in L2, so I press the right arrow key and then up, clear, enter. And that empties out those lists. If you've got something in 3, 4, 5, or any of the others, don't worry about those. We're not going to use those. You can clear them if you want to, but you don't have to. Okay. So what we're going to do is we're going to use list 1 and list 2 as our X and Y values. Okay. So we're going to put all of our X values in list 1 from that table right there. Okay. So 3, 5, 7, 9, 11, 13. All odd numbers from 3 up. Okay. So 3, enter, 5, enter, 7, enter, 9, enter, 11, enter, 13, enter. 6 of them. And then in L2, I'm going to put the corresponding Y value that goes with it in that one. Got to have them paired up in ordered pairs. If you mix up the order, it's going to mix up your scatter plot, which is going to in turn mix up your line of best fit later on. Okay, so make sure you get your ordered pairs in there matching up L1 to L2. So we got 0, 2, 3, 6, 9, 11. 0, 2, 3, 6, 9. Thank you for coming back. Thank you. 11. So after you've done that, check with your table. Make sure you got them all paired up right. Because if you don't have it right at this point, nothing after this is going to be right. Okay? Now, once you've done that, we're ready to make a scatter plot with our calculator. To do that, we're going to hit second and then Y equals. So the second button, the blue one, and then Y equals. And that should get us to the stat plots menu. Okay. The only one we want to be turned on is stat plots 1. So if your stat plot 2 or 3 is off, you can turn them all off at once by hitting number 4. It'll turn them all off if you've got the others on. You probably don't have any of them turned on at the moment. Okay. So I'm going to hit enter on number 1 there to get us to that one's menu. Okay. I want on to be highlighted. If yours was off, then it looks, whoops. Wrong button. If yours was off, then it looks like that. Just move it over to on, turn it on. And then the next row says the type. And the first type is the scatter plot type. That's the one we're going to use. This one is a line plot, so it would connect them all the dots with a line. This is a histogram, if you ever needed to do that. then box and whisker plots, and then that's a modified line plot, which is a little bit different. Not very, you don't use it too much in regular algebra class. It's more of a advanced statistics.
Okay, can we get back there?
Second y equals. Yes, sir. At second y equals, hit enter on plot 1. And then right there where it's blinking on, hit enter. And it'll turn it on. And then it should darken in right there on the top. Do what now? That's plots on. That turns them all on. But the on the second y equals, when you go there, number 4 turns them all off. Number 5 turns them all on. I've never in my life used number 5 because I've never wanted to turn all 3 of them on at the same time. Even in every math class I've ever taken, I've never needed all 3, okay, at the same time. So plot 1 is the only one we want turned on. So I'm there. We want type the first one. Make sure X list is L1 and Y list is L2. Is anybody's not that? I don't want to muddy the water if I don't have to. It should stay that indefinitely. Unless you manually change it, it should stay that. And then the mark, it doesn't matter what mark you pick there. I always just leave it on the first one because it's easy to see and makes it a little bigger than just a little bitty dot. It makes a nice little square there. And then if you've got the color one, you get to pick what color that dot is, but it doesn't matter. All right. Now, what we want to do now is we want to graph that. So I'm going to hit graph. And my window is really messed up right now, and I don't see those points, okay? The way to get to where you can see your points is hit zoom, and we're doing some statistics with ordered pairs out of the stat menu. So number 9 is your option. Zoom 9. And it fixes your window to where it fits those ordered pairs, and you see them, okay? So zoom 9. On that. Everybody's looks something like that. All right. Does that look linear? Yeah. What kind of slope would the line have? Positive slope. Okay. So we look at that. Now, here's the difference in line of fit and line of best fit. Line of fit is eyeballing it. Okay. So what we would do is we would look at that and we would pick two ordered pairs that we think gets pretty close to fitting all of them. Okay, so if I picked this one and this one, it'd be a line going through there, and that gets pretty close to them. Okay, so I'm gonna pick 2. Quiz test form. If I'm asking you to do the line of fit, I'm gonna tell you which 2 to use. Okay, because then if I don't, there's 30 different answers. Okay, so I'm gonna tell you which 2 to use. We're gonna use for this problem. We're gonna use 5-2 and 9-6. Okay, and we're going to write the equation for a line of fit, not the line of best fit, just the line of fit. Okay, so what do we need to do to write the equation of that line? Need the slope. Okay, so 6 minus 2, 9 minus 5, 4 over 4, which is 1. So we got a slope of 1. Now what? All right, so if I use these 2 ordered pairs to get the slope, I need to use one of those to get my y-intercept. So doesn't matter which one, just pick one. It should get the same y-intercept no matter which one you use. I'm going to use 5-2. Okay, so 2 equals 1 times 5 plus b. That'd be 2 equals 5 plus b. Subtract 5. b is -3. So our line of fit is this equation, y equals 1x minus 3. That's our line of fit. If we graph that on our calculator, we can hit y equals and type in 1x minus 3 and graph that line, and it'll show us, hey, that's not bad. That fits pretty good, right? It goes through, looks like 3 of them, but it's a pretty good ways away from this point and these 2 points. So it may not be the best fitting line, but it's a pretty good line. We want to find the best fitting line, and our calculator has a function that allows it to do that, and it does its method of least squares, and it finds the least distance between the line and each point, like the smallest area in between. There's a whole lot of calculations it does to do that. So to do line of best fit, this is what we're going to hit. We're going to hit the stat button. Okay, so in the calculator, we're hitting the stat button. Then we're going to press the right arrow key to get to the calculate menu. And then we're going to hit option for linear regression. So is what we're doing, linear regression. LINREG. There's 2 of them. One of them has it in the form we're used to, AX plus B. The other one has it in form A plus BX. It's just a different form. There's uses for both of them. We want this form. So option 4 is what we want. And if you're using one of the 84s, newest ones, color ones, or the ones we rent out, then you have this coming up. If you don't have this coming up, let me know. Yours doesn't come up there? Same one. It's the same one. Actually, it'll still work. We'll get through this in a little bit. Okay. All right. Now, X list should be list 1. Y list should be list 2. You see here. Grant, you got the same thing? Okay. X used to get everyone second. That's how it's going to change that. To anything you need to. It should constantly have those. That. All right, so yours. Everybody else okay? What's up? Same thing? Yeah. Yours is not right up there, but it will work like yours. What you got there will work. Okay. And yours defaults to this, just like this is. It just doesn't have to be. And we're not going to use anything special on this menu today at all. So I wouldn't worry about it too much. Yours will work like that. All right. All right. X list is L1. Y list is L2. Frequency list. If you had a third list that said, hey, this ordered pair counts 3 times, this one counts once, this one counts 4 times, something like that. That's something you would use more in a calculus-based class. You're not going to have that in it, okay? The store regression equation option, that's an option to put the equation into one of the Y things from your Y equals menu. It's a lot of button pushing for something you could just write down and then type it in, which is the way we're going to do it, okay? So we're just going to go down to calculate. And if you're one of those folks that doesn't have this menu coming up, just hit enter. And it should crank out that equation. You may have an R or an R squared underneath here. That doesn't matter. but everybody should have these same numbers if we all typed in the list correctly. We're going to round this to 2 decimal places. Okay, so the slope would be 1.13. The y-intercept, negative 3.86. So our equation, our line of best fit, is y equals 1.13x minus 3.86. Not much different than our line of fit that we found by hand, but a little bit of difference. Okay. Option 4. Okay. Now, if we graph that with the calculator, hit y equals, and then I'm gonna put in the line. Well, I'm gonna leave that one, x minus 3, and then we're gonna look at the difference in it in 1.13x minus 3.86. And I want you to see the subtle difference in the two. There's not much difference in these. The red one is the line of best fit, and it may not go directly through more points, but it gets closer to all of them than the blue one does. Okay, it's off of this one a little bit. It's off of all of them a little bit, but it's closer to, on average, to all of them. Still not much closer to this one, but it got a lot closer to these up here. Okay, so what your calculator is doing is calculating and getting the line that gets the closest to all the points. And that's a line of best fit. Okay, so we want to be able to find a line of fit and a line of best fit. So let's look at another example. We can go through that again. Here's a set of ordered pairs. This comes from number 14 out of your book. It really doesn't matter where it comes from. It's a set of ordered pairs. -2, -1, 0, 1, 2 are our x values. 76320 is our y values that go with that. So make yourself a scatter plot on the calculator with those points. And then we'll do a line of fit and line of best fit. Freeze this so you can see the order pairs. You want to flip back and forth. So if you don't remember, we're hitting stat, edit, and I'm going to clear these lists. And put in my new ones. I know on the 2 examples we're doing here, the x values have all been in numerical order. They technically don't have to be. As long as your ordered pairs are matched up, I could mix up this. As long as it's matched up with the same y value, it's not going to change how your calculator handles it. Because it's just reading these as a list. It's not really saying they got to be in order. All right, so the y values are 7, 6, 3, 2, 0. Oops. And then what do we do after that? We want to graph those points, right? So how do we do that? Yeah, we can hit graph and then zoom 9. The good thing about this is once you get it set, the plot 1 set up, then you don't have to go back and turn it on and mark everything again. It's already set to do that. It's just going to take your new list 1 and list 2. Once you've got it set to do it the first time, you're good. Okay, I'm going to go ahead and clear out these equations out of my y equals because they're annoying me. But there's my scatter plot. Does that fit a linear relationship? fairly linear. It's not perfect, but it's pretty good. It's what kind of slope should we be finding? Negative. Okay. So let's do the line of fit. Let's find that. So let's pick two ordered pairs to use here. What two ordered pairs do y'all think you want to use? So this one and this one. The first one, the last one would be pretty good too. I don't think it really matters here. I think we're gonna get a pretty decent line no matter which two we pick. I think I probably usually would avoid picking two that are right next to each other just because that really can skew the data or the line a lot. So as long as you pick some that are kind of far apart when you're doing your line of fit. So which ones we want to use again? I'm gonna use. Let's use this one, and 0.3 is always easy to use. That would be an easy one because it makes the math easier, right? If we did 7 minus 3, -2 minus 0, be 4 over -2. So our slope would be -2. And because we used 0.3, what do we know the y-intercept is? 3, because we used something that's on the y-axis. So our equation would be y equals -2x minus 3. Now, how do we get the calculator to find our line of best fit? Or it should be +3, I'm sorry. Because it's 0.3. Shouldn't have been a -3, no way. How do we get the calculator to find our line of best fit? Yes. Good. 4. Calculate. No need to round this one. It got terminating decimals there at -1.8 and 3.6. That's nice. So it's y equals a -1.8x plus 3.6. Are those pretty close together? As far as, -2's not too far away from -1.8. 3's not too far away from 3.6. That should go together. When you do your line of fit, it should be fairly close to your line of best fit. Because you're eyeballing it, your eye is pretty good. You're going to be able to see a linear relationship and get pretty close. Your line of fit and your line of best fit shouldn't be just terribly far off. You got something there. Oh, that should be a +2. Instead of a -3. I think I said -3 earlier, and it should have been plus. And if you graph those, get y equals, graph the -2x plus 3, and then the -1.8x plus 3.6. I'm just graphing the line of best fit. Nearly, yeah, almost. Because that red line is just almost going through that one right at the center, but it's not completely. And then it almost goes through the center of that one, but not right on it. Yeah. And you can usually see that once you do your line of best fit. Hey, I could have picked these 2 points. My line of fit would have been better, but it's not that big a deal. Okay. Like I said, on quiz and test, I'm going to tell you which 2 points to use for line of fit so that we're all looking for the same thing. Okay. All right. That'd be it for today. Page 291, 5 through 25, just a bunch of, some practice with this stuff and building some linear models based on the data you're given.